Hello students, in today's experiment we are again going to find the strength of a base for a neutralization reaction. What is our aim? That we are given a 0.08 normal HCl solution. In today's experiment we are given the known concentration of an acid solution and we have to determine the concentration of a base Na2CO3 in terms of normality and grams per liter. Let us see the reaction once. We are given the strength of HCl, which is 0.08 normal, which is to be titrated with 10 ml of this basic solution Na2CO3 sodium carbonate, which produces our common salt NaCl, CO2, carbon dioxide and water. Right? These are the requirements. We have seen all this apparatus in our earlier experiments also. Let us move to our observation part. Now, let's start with the experiment. Here, there is a 25 ml burette. Now, remember, before starting with the experiment, first of all, you have to clean all the apparatus, that is, burette, the pipette, the conical flask and the funnel with water. You have to thoroughly rinse it with water and then with the respective solutions. Now we'll start with the rinsing of all our apparatus. We'll start rinsing the burette. Repeat this rinsing 2 or 3 times. I have already rinsed it, but to show you, I am doing this. Rinse your funnel because every time, for every experiment, you are going to use a different solution. Rinse your conical flask. After rinsing with water, we will rinse the pipette and the burette with their respective solutions. In our case, in today's experiment, what we have in the burette, this much concentration of HCl is there. So, we will take a little amount of HCl solution and rinse the burette with that HCl solution and rinse the pipette with Na2CO3 solution. Let's start with the experiment. As you can see, we are pouring the HCl solution 0.08 normal. There should be no bubble formation. So what will we do? We will straight away pour the liquid to the bottom of the burette. And note that the lower meniscus of the solution is at 0 level, since we have learnt that for colorless solution we have to note the 0 level at the lower meniscus of the solution. We will take 10 ml Na2CO3 solution through the pipette into a conical flask. Now, for today's case, we are going to use methyl orange as our indicator. This indicator, again, what it gives in basic solution, our methyl orange gives an yellow color. And in an acidic solution, it gives orange color. That's why today's endpoint is yellow to orange. Now, this is our methyl orange. This is our indicator. Okay, the moment the methyl orange gets to the conical flask, you will see that it is yellow in color. Then we will start with the titration you will see that drop wise we will pour the HCl solution and shake it thoroughly and simultaneously to see an orange color. You will notice slight temporary appearance of orange color at the bottom of the flask. This is your final permanent orange color. Now we'll note the reading. We will see that the reading is at 9.6. That day we talked about the least count of our burette. The least count of our burette is 0.1 because between our two readings the difference is 1 ml, and in 1 ml we have a graduation level of 0.1 in each level, right? 1 ml is divided by 10 count numbers. So the least count of one graduation level is 0.1. So 9.6 is our final reading. Let us note our readings here. Our initial readings was 0.0 ml. Our final reading is 9.6 ml. So our difference is final minus initial, that is 9.6 ml. Now for titration, we will again clean our conical flask with water and then we will titrate it. Again you have to fill the burette up to the 0 marking level. And then again titrate it. Now you have to titrate it till you get a constant reading. Suppose our other two readings are also this. So our concordant or consistent reading is 9.6 ml. Our final statement is that 9.6 ml of 0.08 normal of HCl is required for complete neutralization of 10 ml of some normality or some concentration of sodium carbonate. Now, yet we haven't known the concentration of sodium carbonate. So, through our normality equation N1V1 equal to N2V2, we will calculate the normality of sodium carbonate. We know the normality of HCl, that's this much. 9.6 is our burette reading. Divide by 10 through cross multiplication, we will get this as 0.0768. Now, how much amount of sodium carbonate is dissolved in 1 liter of distilled water? To know that, we'll multiply the normality with our equivalent weight of sodium carbonate. So, 0.0768 into 53 comes as 4.0704 grams. So, in our final result, we'll write 0.0768 normal of sodium carbonate was required to completely neutralize the 0.08 normality of HCl.